So in this video I'm going to be going through quite quickly how computers store information using binary. So to start off with, let's look at how we store numbers. So we store numbers like this. This is our number system called denary and or decimal, depends where both words are acceptable. And basically it's a 10-digit system from 0 to 9, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different digits. Okay. So the lowest column, which is sometimes called the least significant bit, is worth only 1. This one is worth 10, this 100, and this 1,000. For the smart people there, you'll work out that this is, if I make in black, there we go, 10 times the previous column. So every time you move to the left, it's worth 10 times it was before. And the reason for that is because there's 10 digits. Okay, if you multiply it by 10 each time, then you can do every single possible number using this system. Now I know we don't do it this way because our heads don't need to do it this way, but this is how essentially these numbers work. This is 8,476, and this is how it really works. It's 8 times 1,000, which is 8,000, 4 times 100, which is 400, 7 times 10, and 6 times 1, and you add them all together and you get 8,476. Now we don't tend to do that because with the 10 system, which is why I think we use it, it's quite easy to do multiplication. So 8 times 1,000 is 8,000. 4 times 100 is 400. So it's not the most difficult math to do. So let's look at binary. Binary uses a 2-digit system of 0 and 1. So because that system only has 2 digits, okay, rather than the 10 digits, the right column is still worth 1, but every time it doubles this time. It doubles because there's a 2-digit system. Okay, so this one's worth 1, 2, 4, 8, 16, 32, 64 and 128. So this is how a computer stores numbers, using zeros and ones. And the reason it does that is because it is made up of electricity. We'll go through this more later, but basically a computer has millions and millions of switches in it that are either on or off. And so that is why they chose to use a binary system rather than the system that we use. So just to clarify a few keywords: bit, that is a single 0 or 1. Okay. Byte is 8 bits. So if you hear the word byte, that means 8 bits. Okay. They're the really two major ones. So 1 bit is a single 0 or 1. 1 byte is in 8 of them at a time. And there is one called a nibble, which is 4 bits, which is very rarely used, but we'll talk about it in case it pops up, but it is sometimes used. And that would represent 4 bits like that. So that's a nibble. A whole byte is 2 nibbles. And a single 01 is a bit. So, won't worry too much about that now because we'll go over that more another time, but just so you've got the basic keywords. So what number is this one here then? I've put some zeros and ones underneath it here. Well, it's like before. You do 0 times 128 plus 0 times 64, but the problem is this gets tedious because 0 times a number is pointless, and 1 times a number is kind of pointless. So to simplify in binary, all you do is you simply add up all the numbers that have a 1 below them here. So here in this case 16 and 2, and you get the answer, which is 18. So 16 plus 2 is 18. So this is the binary representation of 18. Now it is possible, as you can see here, that it's represented by 000100010. You can represent it like this, and those numbers are the same. Okay, you can delete the preceding zeros, just like we wouldn't write 0780. The computer, as you see in Excel here, will automatically remove the 0 and make it 780. However, in binary, people often will still write them in blocks of 8 or 4 or some sort of bit system. They will write the preceding zeros. We don't ever do that in denary, but sometimes they do in binary. But both of those are actually the same number, just with preceding zeros or not. Okay, so hopefully you understand now how to work out what numbers are. You basically add up every number with the 1 below it. If you are given this in the exam and you don't have the numbers, and you just say you've been given, like, I don't know, 10111, so you put 11101. You can, if you want, put 000. You remember you start from the right, and you're like, oh, I can't remember what's on the top row. Well, you just start with 1 and double it to 4, 8, 16, 32, 64, 128. Okay, so you start with 1 and double it, just like in denary, where you start with 1 and times 10, so you'd know the next one is 10,000. So in binary, you know the next one from here should be 256, if you could do that math. So this number here, 10111, would be 16 plus 4, 2 and 1. So that would give you the answer of 23, because 16 plus 4 is 20, 2 and 3. And so that is how you convert from binary to decimal. So complete part 1 of the worksheet, and then we'll go through 1 or 2 of the answers. Not many, because I think you'll do this quite easily. So pause the video now and go through it. So hopefully you've done part 1 of the convert from binary to decimal section. I deliberately didn't put the top row in for fear of the exam not doing that. And you would have to do it yourself, so I don't want to do it myself. So I've put it in, but obviously you don't. So let's just do the first one. I'm probably only going to do the first 2 because it's quite an easy thing to go through. So the first one is 0, 1, 0, 1, 1, 1, 1, 1. 0, 1. So there's a 1 there, a 0 there, and a 0 there. Right, so quite simply, you add up those numbers there, and you get the answer of 26. 16 plus 8 is 24, plus 2 is 26. So that's the first one done. Okay. The second one, a little bit more tricky, is 1, 0, 1. And that would just be those 2 there, and so that should be 129. Okay, nice and simple. You should easily be able to do that. So I'm not going to do the rest of them because hopefully you've got those all right. And there we go. Right, to convert it back from binary to from decimal to binary is a little bit more tricky. There are many ways of doing it. I prefer to just do it in your head and not spend too much time worrying about it, all the techniques that you could use, because the math isn't too difficult. And we'll go through it. So let's have a look at the first one. Let's delete these because they're getting in the way. So the first one here, let's do the first one together, so because then I don't have to go through it. I'll just do any number actually. Let's do 54. So we've got 54. So how do we get a 54 in there? Well, the trick is to look for the biggest number that completely fits into it and put a 1 under it. Okay, so we've got 32 there. So remember, all the numbers that we use, let's highlight this section, so we're going to type all the numbers we put in there, would need to add up to 54. So I've done 32 of them. So how do I get from 32 to 54? Well, hopefully you can work out that I need to add 22 more to this to get to this number. So now I'm on 22. So I look along here and see, right, which is the highest number that goes into 22? So that goes into 22. So 16 does. So I put a 1 there. So now I've got 16. Well, hopefully you should be able to work out that now we're on 48. Okay, and we have 6 left. Now at this point, knowing that there's only 6 left, I just look for the numbers that add up to 6. I should very quickly see that these are the numbers. Do not forget to put the zeros in for the other numbers, because people that do that in the exam will get no marks, because that would just be 1, 1, 1, 1. Just like if I said do 704, you wouldn't just write 74. This would be a completely wrong number. So hopefully you can see that adds up to 54. Now sometimes numbers are easier than others. If you get a very high number, it's often if it's very close to one of these numbers, the closer it is, the easier. Or if it's just like just above the 16, like 19's easy, 37's easy, 129 is easy, because once you've got 1 there, you know you need 1 more. So let's do another one very quickly. Let's do 136. That's a random number. Right, so straight away, you see that 128 goes into that, so we put 1. 128 goes there, and you should now work out that I need 8 more to get to there. So then it's just a single 1 there, and 128 plus 8 is 136. Now those were quite easy ones, so let's try a tricky one. Let's try 120. And the reason that's tricky is because it's not underneath that one, so it's going to have quite a lot of 1s to add up to it. So let's zero these all out. Okay, right, Joel. Yeah, no, I'll leave it fine too. Right, so the biggest number that goes into that is 64. Okay, now I need to get from there to there. So you need to do 128. If you can't sort of just look at that and know that's 56, because 6 onto the 4 would make 70, and then you need 50. Then you might need to do 120 minus 64 in maths, you know, and do the sum, and then see what's left, and you'd work out there's 56, and then just keep doing that. But if you can just do the math in your head, then it's fine. So I've got 56, okay? Now, so then the next biggest number that goes into 56 is 32, so now I've got 32. So if I needed 56, and I've got 32, there's 24 left. Okay, if once again you can't do that, you'll have to do 120 minus 64 minus 32, you know, and then do that sum up there, and then keep going down until you get the number. But hopefully you know that if you needed 56 now, you need 24 left. So 24 on here should work out that 8 and 16 add up to 24, so we just put ones there, and then we get 16 and 8. Okay, and then that adds up to 120. So you try the other numbers on the sheet, and off you go. That'll be part 2. Pause the video, off you go. Right, I'm not going to do too many of these and take too long because this video is getting too long as it is. So what I want you to do is have a quick look at your answers, and let's go through them together. So the first one was 68, so nice simple one, because you straight away see that that is 1 and that is 1, because 64 and 4 add up to 68. It's basically a game of pick the numbers that add up to that. Now some numbers are easier than others. 64 and 4 is quite an easy one. It's a non-calculator paper, so you'll need to be able to do basic mathematics. Let's do 101, a slightly more difficult one. So straight away you know it's 64. So now you might need to do some maths if you don't know how to get to 101. I know that 36 more onto 64 will get to 100, so I need 37. But if not, you're going to need to do 101 minus 64. There's no problem with that. Just do that math like you would in any math paper. If you saw that in the GCSE math paper, you think that was easy as anything. And hopefully you know that 37, you'll work out that that's 37 in the end. And then, you know, you've got 37 left. So, you know, at this point, it's not too difficult to figure out how to add up to 37. And then you just put ones on them there. And then all the numbers that are highlighted there add up to 101. So I'm not going to do the others. You can just get the answers and go and look at them. So, right, last but not least, as a little extension, I want you, because it's very important to know binary, I want you to, using 4 bits, write out the time, the 1 to 0 to 15 in binary. So it should look like this. We're going to use all the preceding bits. So the first 2 look like that. That would be 0 and 1. And then I want you to be able to write 0 to 15 using binary in 4 bits. Off you go.